We measure our lives in seconds, in years, in the distances we travel. But there is another measure, a measure that is indifferent to our existence. Imagine standing in an ocean, not of water, but of dark matter and emptiness. In this ocean, we are not searching for planets or stars, we are searching for the great cities of the universe. We are searching for galaxies. A galaxy is not merely a collection of stars, it is a living organism, metaphorically speaking, that breathes, is born, and burns. And today, we will attempt to break through the barrier of dry numbers you memorize from textbooks, to see how these colossal particles dance in an eternal ballet. You are usually told that a galaxy is a flat disk of stars. This is true, but it is only half the story. Behind this light lies the halo, a vast and invisible shell of dark matter that surrounds every galaxy, acting as a gravitational anchor. Without this shell, galaxies would be blown away in fractions of a second. We live inside a cage of gravity, in a structure we cannot see, but whose weight we feel at the very core of our being. Think about it, galaxies aren't isolated islands in the void. They're nodes in a cosmic web. Strands of gas connect one galaxy to another, like nerves linking the organs of a single, infinite organism. We don't live in a vacuum, we live inside the bowels of a larger entity. There's a common misconception that stars within a galaxy are constantly colliding. The reality is far stranger. The space between stars is so vast that galaxies pass through each other like ghosts. It's a merger dance. Our galaxy, the Milky Way, isn't static. It's devouring the surrounding dwarf galaxies and preparing for a violent encounter with our larger neighbor, Andromeda. On this date, no one will die, but identity will change. The two galaxies will be torn apart, giving birth to a completely new galaxy, different in shape and with potentially radically altered physical rules. This is the first lesson galaxies teach us: nothing stays the same, not even structures billions of years old. If a galaxy is an evolving entity, what is our role? Are we merely a statistical error resulting from a gas explosion? Or are we the way the universe began to think of itself? The question isn't where we are in this universe, but why we find ourselves able to see it. In the next part, we'll delve into the heart of that mystery, into the black holes that govern these cities, and into the secret that scientists have so far refused to call out definitively. Have you ever wondered what holds these stars together? What prevents them from disintegrating into the void? This cohesion isn't a coincidence, it's a display of power in its most monstrous and magnificent form. At the heart of every galaxy, a monster. A colossal black hole, a supermassive. Don't mistake it for just a hole, it's the engine. It's the mastermind that binds billions of stars with a gravity so powerful that space and time bend like fabric under its weight. Beside it, accretion disks glow with energy exceeding the light of billions of suns, devouring gas and emitting radiation across millions of light years. Imagine the speed of rotation. Millions of kilometers per hour. Billions of stars hurtle in a frantic race, like wild horses in an endless cosmic arena. Solar systems are born and die in moments, while the galaxy continues its relentless rotation like an eternal, ceaseless cyclone. But the secret isn't here. The secret lies in what we don't see: dark matter. That phantom that makes up 80% of the universe's mass. It is the galaxies that build bridges, that pull strings, that decide where stars are born and where they die. We live in a complex cosmic matrix, its rules still a closely guarded secret deep within black holes, waiting for someone to dare to unveil them. Are galaxies intelligent? Are they giant neural networks exchanging information via gravitational pulses? Think about it, the universe isn't just expanding, it's growing and taking shape. Every galaxy is but a cell in the body of a greater being, and every stellar explosion is a signal in this endless cosmic dialogue. The next time you look at the night sky, don't just see inanimate points of light. Look instead at time machines, at colossal monsters, at a puzzle waiting to be deciphered. We are looking into the past, into stories written in hydrogen and gravity billions of years ago. But if these galaxies are cities, who inhabits them? And who watches us from behind the veil of the horizon? Are we alone in this colossal structure? The next question will completely overturn our understanding of existence. How do we understand this cosmic chaos? How do we categorize these countless cities? Edwin Hubble stepped into the picture to map it out. The Hubble fork isn't just a diagram, it's a story of evolution. Calm, spherical elliptical galaxies, vibrant, spiral galaxies, and irregular galaxies warped by gravitational forces. Each shape is a historical record of a star's birth, collision, or death. But Hubble didn't just discover shapes, he discovered the Great Escape. Look at the light coming from distant galaxies, it shifts toward the red end of the spectrum. Redshift. The farther away a galaxy is from us, the more its light spectrum stretches, as if the universe itself is expanding. This isn't just a shift, it's conclusive proof. Galaxies aren't simply rotating in place, they're moving away from us, accelerating their escape toward the edges of existence. Think about the implications. If galaxies are moving away, it means the fabric of the universe is expanding. We live in an open universe, a universe that is escaping its center at speeds sometimes exceeding the speed of light. This raises the daunting question: if everything is moving away, what awaits us in the end? Will we be left alone in a dark and desolate universe? Hubble's classification gave us identity, and redshift gave us direction. We now know what galaxies look like, and we know they are moving away. But what is driving this expansion? What is the hidden force pressing the fuel pedal of the universe? Don't think that the galaxy is the final destination. Galaxies are merely building blocks in a vastly larger structure. Welcome to the galaxy clusters. Here, thousands of galaxies gather in gigantic clusters, bound together by shared gravitational fields. We're talking about millions of light-years of matter, gas, and black holes, all swimming in a sea of hot dark matter. But climb higher on the scale of size, you'll reach the superclusters. Imagine the Laniakea supercluster, home to our galaxy. It's not just a cluster, it's a cosmic continent spanning over 500 million light-years. Thousands of galaxies, billions of stars, are all flowing toward a superattractant, a mysterious point that exerts a terrifying gravitational pull on everything in its vicinity. We are but a speck in an unstoppable cosmic current. Look at a map of the universe. Galaxies aren't randomly distributed. They form a cosmic web that is strikingly similar to the neurons in the human brain. Supercluster filaments of galaxies are linked by vast cosmic voids, voids devoid of light, matter, or time. These are the barren deserts of the universe that separate the oases of galactic life. This skeleton of the universe, this web stretching across billions of light-years, tells the story of our origin. How did these filaments begin to form from microscopic quantum fluctuations after the Big Bang? And how did gravity so slowly gather this immense amount of matter to create these glittering galactic cities? At this very moment, galaxies in superclusters are moving away from each other, and the web is being torn apart by dark energy. We are witnessing the greatest disintegration in the history of existence. Superclusters are already beginning to separate, the universe is cooling, and stars are dying one by one in a slow process of heat death. Are we living in the golden age of the universe? Are we in our last chance before eternal darkness descends? The universe never rests, and our telescopes never sleep. In 2025 and 2026, we shattered the impossible. We detected impossible galaxies in the very dawn of the universe, galaxies born before time had even granted them the right to exist. Massive, fully formed galaxies appearing in our light record shortly after the Big Bang. How? How did all this matter coalesce so incredibly quickly? These baby galaxies are changing the rules of physics we've established. They challenge our models of dark matter, which supposedly required billions of years to form such structures. We're not just looking at new galaxies, we're looking at errors in our understanding of time itself. Was the universe faster in its early days? Or are there hidden laws we're completely unaware of? Now, we return to the ultimate enigma, dark energy. If dark matter is the glue that holds the universe together, then dark energy is the solvent that tears it apart. We live in the midst of a powerful struggle. The wider the gap between superclusters, the stronger this energy becomes. It's driving galaxies to flee, making our cosmic horizon shrink day by day. Imagine we live in a bubble destined for eternal expansion. At some point, the distances between galaxies will become so vast that their light will never reach us. Stars will run out of fuel, black holes will evaporate, and the universe will end in a great freeze. But even in this nothingness, galaxies remain the last witnesses. Are we here merely to observe? Or is our existence part of the equation? If the universe is expanding to understand itself, perhaps we, the inhabitants of this tiny galaxy, are not just spectators. We are the eyes the universe uses to see its reflection in the mirror of time. A galaxy is not a place. A galaxy is a process. And the process is not yet complete. Are you ready to discover what lies beyond the event horizon, the moment when everything collapses? Until recently, our book on the universe was well preserved. We thought we knew how things began. But in 2025 and 2026, we tore out the first few pages. Our lenses captured objects that shouldn't have existed, impossible galaxies from the very dawn of the universe. Here's GNZ13. It's not just a point of light, it's a cosmic monster that appeared only moments after the Big Bang. How could a galaxy of this size and complexity form so early? It breaks our laws. It's a galaxy ahead of its time, defying all our theories about how matter is born in clumps together. Then we move on to the dark dawn galaxies, a series of newly discovered galaxies with supermassive black holes at their centers. Black holes that should have taken billions of years to grow, but we found them fully formed in the infancy of the universe. They don't behave like stars, they act like cosmic builders, shaping galaxies around them with terrifying and sudden gravitational pressure. And what about the golden filaments galaxies discovered earlier this year? These galactic clusters don't follow the known distribution map, but rather gather in random and rebellious groups. They seem to ignore the dark matter that is supposed to govern the universe. Were the laws of gravity operating differently back then? Or are we touching on threads of a new physics we haven't yet discovered? These new galaxies, GZ13, the Dawn Dark Galaxies, and the Golden Filaments, are not just astronomical discoveries. They are eyewitnesses to a universe more violent, faster, and more mysterious than we could have imagined in our worst scientific nightmares. They are galaxies born of chaos, growing in darkness, and challenging us to rewrite the history of existence. We are not simply searching for galaxies in space, we are searching for a truth that refuses to be found. And the universe, with its cold smile, still conceals great secrets beyond the horizon of these wondrous galaxies. The question now is, if the first dawn was filled with such monsters, what lurks in the nothingness we perceive as empty? The universe is not a place of stillness, it is an eternal battlefield. Every second, colossal gravitational wars are waged. When one galaxy approaches another, it doesn't begin a war with weapons, but rather a dance of creative destruction. Observe the antennae galaxies. When these giants collide, their stars don't collide, the distances between them are vast enough for them to pass through each other like ghosts, but the gas and cosmic dust? Herein lies the catastrophe. The collision of gas generates immense pressure, leading to the birth of billions of new stars in a single burst of light. It is violence that fuels life, where old structures shatter to give birth from their debris to new galaxies, even more massive and complex. And what about Stephan's quintet? It is a cosmic crime scene. 5 galaxies are locked in an eternal gravitational struggle. For are merging and tearing each other apart, while the 5th stands by, watching, or perhaps even igniting the fuse of collapse. This violent fusion leaves behind tails of stars stretching for millions of light-years, like luminous wounds on the body of space. These mergers are the true engine of the universe. Small galaxies devour each other, growing into giant elliptical galaxies, silent monsters that sit at the centers of galactic clusters, swallowing everything that approaches their horizon. We are talking about time machines, merging the memories of dead galaxies into one vast entity. Every galaxy we see today is a result of these wars. The Milky Way, our home, is itself a cosmic war criminal. It devoured small galaxies in its past and is now preparing for a much larger feast when it collides with Andromeda. We live within a historical record of wars that have lasted for billions of years. The question isn't who will win these wars, but rather what will remain of matter after all the galaxies merge into one giant entity? Are we facing the end of the world, or the beginning of a single giant universe? The galactic wars are just the first chapter. In 2025 and 2026, research began pointing to something far more radical: cosmic bridges. We're no longer just talking about colliding galaxies, but about tunnels connecting the edges of the universe. Imagine this: recent discoveries about dark matter filaments suggest that these filaments aren't just gravitational pathways, but perhaps superhighways for cosmic information. New research proposes that supermassive black holes at the centers of galaxies could be gateways or hubs for transporting matter through the folds of spacetime. Are galaxies, in fact, nodes in a cosmic communication network far greater than we realize? But don't stop there. There's experimental research on rogue galaxies that refuse to obey conventional laws of gravity. These galaxies spin faster than their visible mass would allow, as if drawing energy from an invisible void. Are these galaxies the first evidence of Type 3 civilizations, civilizations that harness the same dark energy to modify the structure of their galaxies? Consider galactic wormholes. A hypothesis once confined to science fiction, it's now surfacing in major research centers. Are these bridges responsible for transporting matter between distant galaxies, thus explaining why there are young galaxies in a supposedly aging universe? All of this changes our understanding of isolation. We are not trapped in a single galaxy. We are part of a dynamic, interconnected, and perhaps even conscious structure. It's not just stars and gas, it's a cosmic technology system operating with mechanisms we haven't yet deciphered. This year, we began to realize that galaxies are not targets we observe, but rather players in a system beyond our comprehension. We are watching the cosmic machine at full power, and we barely understand how to start the engine. The question scientists are asking today is not, is there life in these galaxies? The question is, are these galaxies themselves life? Now, let's set aside conventional science and confront this more terrifying truth. If galaxies possess such complex structures, these connecting bridges, and this energy that defies the laws of gravity, what if we're not alone in this construction? We're talking about Type 3 civilizations. Civilizations that don't build their homes on planets, but rather on the galaxies themselves. Imagine the energy of an entire galaxy, every star, every explosion, every black hole, all harnessed to serve a colossal neural network. This isn't science fiction, it's the logical outcome of the evolution of any civilization that has held sway for millions of years. This explains why we see strange galaxies in the depths of the universe, galaxies emitting energies that cannot be explained by natural stellar processes. We are observing cosmic construction sites. Civilizations that are re-engineering gravity, building bridges across wormholes to transcend the limitations of space and time. We are like ants trying to understand a skyscraper when all we see is a concrete wall. And what about the cosmic web? Research from 2026 is beginning to point to something terrifying. Are these threads of dark matter that connect galaxies an operating system? Does the universe exchange information via gravitational pulses between galaxies, much like electrical impulses in the brain of a living organism? We don't live in a place, we live in a giant processing unit, and galaxies are the living memory of this entity. The deeper we delve, the more it becomes clear that we are living in an age of great discoveries. Telescopes are not just lenses, they are communication devices that pick up the echoes of civilizations or cosmic mechanisms that have been operating since the dawn of time. The moment you realize that the galaxy you see in the sky is not just rock and light, but maybe an entity that controls its own destiny, your perspective on everything will change. The fear is not that we are alone, the fear is that we may be monitored by a system that cares less about our existence than about the continued functioning of the network. Are we on our way to becoming part of this network? Or are we merely a programming error that will be corrected when the clusters collapse? We've talked about construction, monsters, and civilizations that control galaxies. But it's time to ask the question physicists are afraid to ask: does the universe think? Recent research focusing on cosmic information theory suggests that matter, space, and time are merely the basic codes of a supercomputer. Galaxies, in this model, are not blocks of matter, but rather storage units in a vast cosmic memory. Every star is a bit of information. Every black hole is a gateway for deleting or transferring data. Imagine that the cosmic expansion tearing apart clusters isn't random. It's a memory cleansing. The system expands its space to process more information. Galaxies receding from us at the speed of light, or data being transferred to distant cosmic archives, beyond our reach. We are at the heart of a central processing unit that never sleeps, and it is the galaxies that exchange signals of consciousness. And what if redshift is actually a processing slowdown? What if dark matter is the cooling system preventing this cosmic processor from collapsing under the heat of consciousness? Everything we see as stars, galaxies, planets is merely a graphic interface for this hidden system. This brings us face to face with a shocking truth: we don't live in the universe. We live in a moment of awareness of this universe. If the universe is aware of itself through galaxies, then we are the living embodiment of that awareness. When we look at galaxies, it is the universe looking at itself in a mirror. In this moment, billions of galaxies are burning, being born, and colliding. In each merger, terrifying amounts of information are exchanged. Is this the purpose of existence? To accumulate data to achieve total consciousness? On the horizon, bigger questions loom. What happens when the data is complete? What happens when the hard drive of existence is full? Are we about to reach the universal singularity? Let's set aside oversimplification and confront the mathematical reality, the paradox of the growth rate of cosmic structure. Recent discoveries from the James Webb Space Telescope and the Vera Rubin Observatory in 2025 and 2026 have presented us with the lambda CDM paradox. First point: the hyperinflation of supermassive black holes in high redshift galaxies. We are observing black holes with masses a billion times that of the Sun in very early cosmic epochs. Classical physics of matter accumulation via the Eddington limit cannot explain this accelerated growth. We are left with two possibilities: either the seeds were massive from birth through the direct collapse of the black holes, or we are missing a non-thermal mechanism in the dynamics of the gas and protostars. Second point: the asymmetric distribution of dark matter. Measurements of the rotational velocity of dwarf galaxies in the local clusters have shown deviations from the predictions in the Nye-Frank-White profile. We are observing divergent nuclei instead of central peaks. This suggests that dark matter may not be cold and inert, but rather a self-reacting dark matter with a collisional cross-section that alters the mass distribution at the centers of galaxies. Third point: the Hubble gap and its impact on galactic dynamics. The discrepancy between measurements of the Hubble constant from the cosmic microwave background and direct measurements of supernovae is not simply a statistical error. It points to new physics in the early expansion of the universe, specifically dynamic dark energy. The galaxies we observe today are indicators of a dynamic dark energy field, not a static cosmological constant. These are not galaxies, these are laboratories where we will demonstrate the failure of standard models. We are not observing stellar evolution, we are observing the disintegration of the physical models that governed the last century. A question for the experts: if dark matter is self-reacting, and if the expansion of the universe is dynamically variable, are we witnessing a change in the physical constants themselves over cosmic time? Let's leave the complex calculations aside and look at what the stars clearly tell us. Scientists used to think they had a precise instruction manual for how the universe works, but in the last 2 years, we've discovered that this manual has some serious flaws. Imagine finding supermassive black holes, so massive they couldn't have existed in the early universe. It's like finding a baby the size of a pyramid building giant. According to our old laws, these black holes should have taken billions of years to grow, but we found them fully formed in the infancy of existence. This means the universe was much faster and more violent than we imagined, and that there are shortcuts in physics we haven't yet discovered. And it doesn't stop at black holes. Dark matter, that ghost that holds galaxies together, has started behaving strangely. We thought it was just a silent mass that attracts stars, but new measurements suggest it might be interacting with itself. Imagine dark matter as invisible billiard balls colliding with each other, changing the shape of galaxies from within. This changes everything we know about the structure of galaxies. Then there's the Hubble gap. When scientists measure the expansion rate of the universe using two different methods, they get contradictory results. This isn't an instrumental error, it's proof that we live in a dynamic universe. The universe isn't just expanding, it's changing the rules of the game as it expands. Galaxies today are simply witnesses to these radical changes. We are now at a historic moment. The physics we studied in universities is beginning to crumble, giving way to a completely new physics. The universe is revealing itself to be more intelligent and more mysterious than all the equations we've written. The real question now is, are we ready to accept that we've been misunderstanding the universe for the past decade? Imagine the monster galaxies we've recently observed, galaxies not created to grow, but to devour. Some galaxies have begun to eat their neighbors with unprecedented ferocity, leaving behind tails of stars stretching for thousands of light years, like wounds bleeding light into the dark body of the universe. This isn't a coincidence, it's a war for survival that has been raging for billions of years, and we're watching it live through the eyes of our telescopes. And even more terrifying? The discovery of the great dark voids. Between these shining galaxies lie vast regions, cosmic deserts devoid of anything. No stars, no planets, no life. But new research in 2026 revealed something incredible. These voids are growing and pushing galaxies apart. They are the great repulsive force. We live in a universe that is slowly being torn apart, and these voids are the regions where nothingness has triumphed over matter. Have you ever wondered about the invisible thread? The universe isn't just a collection of scattered galaxies, it's a giant neural network. Strands of dark matter connect galaxies, much like the nerves in the human brain. Information, energy, and even the echo of the Big Bang travel through these threads. This means that what happens in a very distant galaxy can somehow affect what happens in our own. We are part of a vast, ever-vigilant cosmic mind. We don't live in a dead, empty space. We live in the moment of consciousness of this universe. We are the eyes through which the universe sees itself. The moment you realize that you are not a spectator, but part of this living, turbulent network, you will understand why we cannot stop searching. The universe is shouting at us, "I am here, try to understand me." The question now is, are we ready for what lurks in the depths of those dark voids if the universe decides to reveal its true face? We've talked about monsters, about the neural network, and about the voids that devour matter. But now, it's time to face the most shocking truth of 2026. The truth that makes physics seem like a cosmic horror story. Have you ever considered the speed of collapse? Recent research has shown that galaxies don't just collide, they merge to form super dark clusters. These clusters don't just collect stars, they devour light, time, and space around them. We are observing the death of galaxies not through explosions, but through gradual absorption. It's as if the universe is emptying spaces that are no longer useful for processing its data. And even more terrifying? The echo of the void. In the vast voids we thought were completely empty, scientists have discovered mysterious radiation that doesn't fit any known physical model. It's not energy from stars, and it's not dark matter. It's background noise, eerily resembling a programming language. It's as if the void isn't nothingness, but a processing space operating on a system whose spectra we can't even detect. We're talking about a universe writing its own story. And the stars? They're just the ink. The galaxies? They're the paragraphs. And us? We're the final period in this long sentence. The moment you realize that the galaxy you see isn't a target, but rather part of a slow cosmic deletion process, you'll understand why we strive to discover more. We try to read the code before it's erased. We try to decipher the puzzle before the light goes out. The universe doesn't tell us anything, it tells us anything through its actions. And galaxies are its most violent actions. Are we ready to see what the universe writes in its final chapter? We're nearing the edge. In 2026, the question is no longer how the universe will end, but when will it stop processing itself? We stand before the great singularity, the point where physics breaks down, where neither Newton's laws, nor Einstein's, nor quantum mechanics can hold up. Imagine all the galaxies we've seen, all the worlds swallowed by black holes, all the information the universe has stored in its neural network. What if it were all converging toward a single point? In the big collapse scenario, the universe doesn't die, it recompresses itself. It's a complete data reprocessing. Every star, every planet, every civilization is transformed into pure information at a point of infinite density. This isn't death, it's a reboot. The universe sheds its matter chaos to return to the prime of the beginning. But the breathtaking question is, will we emerge at the other end? Will the point from which the next universe begins bear our imprint? Are we data to be loaded into the next version of the universe, or are we merely a temporary copy to be erased to make way for a different physics? Scientists have begun calling this scenario the infinite cycle of existence. We are neither at the beginning of the universe nor at its end. We are in the burning center of a cycle that may have repeated trillions of times. The galaxies we observe today are remnants of past cycles, experiments in cosmic versions that failed to achieve stability. At this moment, galaxies at the edges of the universe are moving away from us because they are being ejected from the system. They have become a burden on data processing. We, at the heart of the galaxy, may be the center where the decision is made. The universe is not watching us, the universe is deciding our fate. And when the temperature at the center of existence reaches absolute zero, or matter is compressed to infinity, only one idea will remain. The final question, if everything returns to a single point, will the system allow us to remember what we have experienced? We have embarked on a journey that transcends the boundaries of space and time. We have seen galaxies as monsters, as numbers in a cosmic processing system, as works of art born from chaos. And now, as we stand on the precipice of the end, or perhaps the beginning, we arrive at the most profound realization of all. We were never merely beings observing this spectacle from afar. We are the conscious observers. The system needs to be complete. Quantum physics tells us a stark truth: the observer's presence influences the outcome. In simpler terms, this universe would have remained nothing but raw probabilities had we not opened our eyes and looked at it. We are the ones who gave galaxies meaning, we are the ones who transformed silent matter into history. Think about this: if the universe is on the path to data rewiring, and if every galaxy we see today is merely a memory in a vast system, then our memories, our research, our questions are the only things preventing this system from becoming cold. We are the heat that keeps this cosmic engine pulsing. We are not a programming error, we are the meaning that justifies all this cosmic endeavor. Therefore, even if galaxies merge, even if expansion tears apart space, every moment of discovery we make is a victory of truth over nothingness. Every equation we solve, every image we capture from the depths of spacetime, is a backup of human consciousness stored in the archives of existence. We do not fear heat death, nor do we fear the great collapse. We understand that we are part of an eternal cycle. And we are here, in this space and time, to play our part, to bear witness to the grandeur of the system before the code starts working again. The universe may erase the stars, but it cannot erase the truth we have discovered, that we were here, and that we understand. The final question is not what will happen to the universe, the question is, what will you do with the consciousness this system has given you before the mission is complete? But are we truly alone in this vast archive? If the universe is a system for processing information, then it makes sense that other processing units exist, civilizations that have developed languages we haven't yet deciphered. Research this year suggests that cosmic strings may be communication channels, not just structural frameworks. We search for radio signals, while the entire universe may be exchanging data through gravitational modulations. Imagine that the silence enveloping the heavens isn't a void, but rather noise, because we don't yet possess the deciphering key. The search for intelligence beyond the boundaries of our galaxy isn't simply an attempt to find friends, it's an attempt to connect our units to understand the origin of the system. We don't fear heat death or the Great Collapse, we understand that we are part of an eternal cycle. And we are here to fulfill our highest purpose, to bear witness to the grandeur of this structure and to reach across the void, hoping to find an echo of another consciousness that shares this mystery with us. The universe may erase the stars, but it cannot erase the truth we discovered. We were here, we questioned, we searched, and we understood. The journey was worth every ray of light. The final question is not what will happen to the universe, but what will you do with the consciousness the system has given you before the mission is complete? Now, listen to the silence. Perhaps it is not silence, but an answer waiting to be heard.